In this video here, we're going to take a look at modeling a project. Now let's just say then that we're responsible for the completion of a complex project with multiple activities, and some of these activities cannot be started until others have been completed. The question here then is there a way that we can organize the activities efficiently in order to avoid any unnecessary delay? So to begin with here, let's just start then with some definitions. So a precedence table or dependence table, whichever name you prefer here, is a table which shows which activities must be completed before others are started. So this here then is an example of a precedence table. As you can see then, in the left-hand column we've got our activities here, and on the right-hand side we have our dependencies. Now a precedence table helps us to represent a project in a way that we may be able to coordinate the activities efficiently. However, a diagram might be a better way to represent a project, especially if the project is more complex. So let's just take a look then at how we can represent a project visually. So to represent a project visually, what we can do then is transfer the information provided in a precedence table to an activity network to give a visual representation of the project. And you should also be aware here then that there are two types of activity networks, but we're only concerned about one here, and that is the activity on archetype. And in an activity on arc network, the activities are represented by arcs. Clue is in the name. And the completion of those activities, known as events, are shown as nodes. So what I've got here then is the precedence table from the previous slide. And a visual representation of this precedence table here would look like the following. So this here then is our activity on arc network. So each arc then is labeled with an activity letter. As we can see here, activity A, activity B, activity C, activity D, so on and so on. The beginning and end of an activity are shown at the ends of the arc. So this here then is the beginning of the activity, so the beginning of activity A, and this here then is the end of activity A, okay? And the arrow here is used to define the direction, as we can see here then on our network. And the convention is that we use straight lines for arcs, okay? Now the nodes are numbered starting from 0, as we can see here. However, this can sometimes be 1, but throughout these videos here, you'll always see 0 for the starting node, okay? And we call the starting node here the source node. So this is an important definition here. Please learn this. We number each node as it's added to the network. So the starting node here is 0, the next node is 1, the next node after that is 2, 3, 4, 5, so on and so on, right? You get the idea. It's pretty straightforward. And then finally here, the final node is what we call the sync node. So this node here is our sync node. So we have the source node here, the starting node, and the final node, which we call the sync node. Okay? So there we have it then. That concludes this introduction here to modeling a project. So all we need to do now is just put all of this together and work through a practice question together. So let's not waste any more time then, and let's just get started with this practice question. So let's just get started here then with this practice question. Now what we're told here then is a diagram below shows an activity network for a project. So we can see the activity network here, as mentioned. And all we want to do here then is just complete the precedence table to represent this project. So over on the right-hand side here, we have our precedence table. In the left-hand column, we have all the different activities. So activity A through to activity I. And then the right-hand column here, as we can see, it's currently blank, but this would be the dependencies, right? That's what we need to complete. So let's get started here then. Now, starting off from the source node here, we have activity A and activity B. Now, as we can see then, activity A and activity B are not dependent on any previous activities, right? So for activity A and activity B in the precedence table, you just put a dash here, right? And that indicates then that they're not dependent on any previous activities. Now for the next activity here, activity C, so we locate activity C on the activity network. That's this activity here. And I can see then that activity C is dependent on activity A. So in other words, activity A must be completed before we can start activity C. So C then is dependent on A. Hopefully, nice and straightforward. What about activity D then? So we locate D here on the activity network. And again, what I can see here is activity A must be completed before we can start activity D. So I also put A here for activity D as well. Now, what about E then? So for activity E here, again, we work backwards. So looking backwards here from this node, I can see then that activity B must be completed before we can start activity E. So I put B here then for activity E. What about activity F then? So we locate F here on the activity network. Again, working backwards here, I can see then that activity B must be completed as well before we can start activity F. So again, I just put B here for activity F. And hopefully you can see that the process then of completing the precedence table is pretty straightforward, right? Especially if we've already got the activity network such as this here, already fully complete. The process is pretty straightforward. So for activity G then, locate activity G on the activity network. What activities then must be completed here before we can start activity G? Well, it's just the one single activity here, and that would be activity D. So activity D, I'm losing the ability to speak now, but activity D must be completed before we can start activity G. I'm saying the word activity too much, but hopefully you can just about follow. So I put D here like so. What about activity H now? So again, we locate activity H here on our activity network. So again, we work backwards here. So what activities, or might just be one activity here, must be complete before we can start activity H? Well, in this case here, there's two different activities, right? Working backwards then, I can see activity C and activity E must both be complete before we can start activity H. So we put C and E here for H. Like so. And then finally, for the very last activity here, that is activity I, what must precede this? So I can see then, just looking at I here on our activity network then, that activity F here must be completed, right? So working backwards then, I can see here that activity F must be completed before we can start activity I, okay? So we put F there for activity I, and there we have it. We've completed the precedence table here to represent this project, and that gives us the solution to the one practice question for this video. And that actually brings the end then of this video here on modeling a project.